dividing with scientific notation. So remember, with multiplication, when we multiply in scientific notation, we add the exponents. With division, we subtract the exponents. So that's very important. So let's look at a question. What if you saw something like this? 12 times 10 to the third power divided by 6 times 10 to the second. So we're going to line, we can do it like this. We can say 12 times 10 to the third, make it like a fraction. Okay, and you can divide the integers. 12 divided by 6, you know, is 2. So you have a 2 there. We're going to keep the same base. Remember the law of exponents, same base. And subtract. 3 minus 2 is 1. And you don't have to put the 1 there. If you want, you can. It's the same thing. So it's 2 times 10 to the first power. Which is also, I'll write it up here, 2.0 times 10 to the first power if you want to put the 1. Sometimes you don't see the 1, but the 1 is there, even if you don't see it. And what is 2 times 10 to the first power? We just move the decimal once. It's 20. Okay, so let's do another one. Okay, let's say we had 7.8 times 10 to the 9th power. Remember, that's the division sign also. Divided by 3 times 10 to the negative second power. So see what you get if you did that. So 7.8 divided by 3 is 2.6. We know we're timesing it by 10. And 9, now it's not 9 minus 2. This is a common mistake. Remember in division, it's subtraction. So it's 9 minus minus 2. It's 9 minus minus 2. And you remember the laws, keep change. That turns into 9 plus 2. So this will be 2.6 times 10 to the 11th power when you divide that. That's a negative 2. Remember, 9 minus minus 2. Let's look at a word problem. This one is from your book. So here we have, Earth has a mass of 6 times 10 to the 24th kilogram. That's Earth's mass. And Jupiter's is much bigger. It's 2 times 10 to the 27th. Yes, Earth has a 6 and Jupiter has a 2, but remember, Jupiter has a higher exponent to the 27th power. It's a lot bigger than to the 24th power. So the question is, how many times greater is the mass of Jupiter? Anytime you see how many times greater something is, you know that's division. That's a key that you know you have to divide. So what would you do? You know you have to divide, so what would you put on top to divide? You always want to put the bigger number on top. Okay, so let's look at it here. Here's Jupiter. It's 2 times 10 to the 27th power divided by 6 times 10 to the 24th power. So what do you have when you do that? So remember, it's not 6 divided by 2, it's 2 divided by 6. Right, so if you do 2 divided by 6, you're going to get a decimal. It's 0.3 continuing. Let's just put 0.33 for now. And we have to change this. Remember, in scientific notation, we need the decimal after the first number. But let's keep it like that for now. And 27 minus 24, remember, it's subtraction with division. You get 10 to the third. So it's 0.33 times 10 to the third times greater, but we want it in scientific notation. So we're going to move the decimal this way. So if we already moved it once, now we can put it as a 2, because we had to go 3 times this way, but if it's already here, now we only have to go 2 to make the same amount. So Jupiter's mass is 3.3 continuing times 10 to the second power greater than the mass of Earth. And what is that? So it's, if you want to know the number, move it twice. 330 times greater is Jupiter's mass, not math. Try this. See what you get. Which number is bigger? Well, now it doesn't matter which number is bigger because this one comes first. Whatever comes first has to go on top. So it's 15 times 10 to the negative second divided by 2.4 times 10 to the negative 4. So try that. Okay, so the integer will be 6.25. It's already in scientific notation with that 0.25, so we're good there. Bring down the power of 10. Now this is minus 2, negative 2. It's negative 2 minus minus 4. That's what this is, minus 2 minus minus 4. Keep change, change, and you'll get to the second power. That's an exponential form. And in standard form, you move it twice, and you get 625. So, if you ever get a question which says, which number is greater and how many times? Which number is greater? Would it be 3 times 10 to the 4th power or 3.1 times 10 to the 3rd? Well, the number that has the greatest exponent is the greater number. So we know this one's the greater number. How much greater? Divide. 3 times 10 to the 4th divided by 3.1 times 10 to the 3rd. What did you get? So if you divide that, you're going to get a long number. So it's going to be 0.96. We can stop there. Well, let's put one more number. 0.967 times 10 to the 1st power. Now remember, you don't really have to put the 1 there. This is not in scientific notation, right? We have to fix it. So it's going to be 9.67. Now, this is saying to go 1. But if we're already there, we don't have to go at all. We don't have to do anything. So what would the exponent be? 0. 0 means don't move it. So this would be the answer. Now, if you didn't understand that, remember, it was 0.967 times 10 to the 1st power. So it says move the decimal once, and you'll get 9.67. 9.67 times 10 to the 0 power means you don't have to move the decimal at all. So it's 9.67. Remember, any number to the 0 power is 1. So they're the same number. Let's look at another word problem. This one is also from your book. Pioneer 10. It was 12.1 times 10 to the 9th kilometer from Earth in 2002. By the way, Pioneer 10 is way past our solar system now. Well, not way past it. It's past our solar system. It escaped our solar system, and it was launched in 1972. But that's really not important right now. So actually, it's not sending any more signals anymore. 2007 was the last signal that we received from it. But in 2002, it was sending signals still. And the radio signal traveled at a rate of 3 times 10 to the 5th kilometer a second. Now be careful when you see these. Second. Keep that in mind. But the question says, how many hours did its signal take to reach Earth? They're giving us the rate in seconds. So we need to first know, what is the rate in hours? And in order to do that, you need to know, well, how many seconds are in an hour? So there's 60 seconds in 1 minute, and we know that, and we know there's there's 60 minutes in 1 hour. So it's just basically 60. It's 3,600 seconds. So there's 3,600 seconds in 1 hour. So that's the first thing you need to know, because we need to know how many hours, not seconds. So we need to know its rate. If it's going 3 times 10 to the 5th kilometer a second, if we want to know how fast it's going in an hour, we need to times 3 times 3,600. So try that. Alright, so again, we want to know 3 times 10 to the 5th power times 3,600. Now you can just do 3 times 3,600 and fix it from there, or if you want, you can do 3.6 times 10 to the, and here's it, so here's the decimal, and we want to move it 1, 2, 3, so it'll be 10 to the 3rd. If we move it 3, we'll get 3,600. Okay, and if you did 3 times 3.6, you'll get 100 and get 108. You get 10.8, I mean. Don't forget there's one decimal place. 10.8 times 10 to the 8th power. Remember, multiplication you add. But we don't want to the 8th power. Remember, we're moving this. We have to move this once back. So So it's 1.08. Now we have to add a number. Remember, it's 8 going this way, but if you go back 1, you have to add it till 9. So it's 1.08 times 10 to the 9th power. Okay? So that's how much it's going in 1 hour. 1.08 times 10 to the 9th power. Now, if you didn't do it that way, if you did 3 times 3,600, you'll get this number. You'll get 10,800 times 10 to the 5th. But remember, in scientific notation, you have to make it that way. So if that's the decimal, how can you get the same number? 1, 2, 3, 4. You have to add 4 to that 5. And that's where we got that 9 from. So that's how much is going an hour. So what you do is you just divide. You've got to divide 12.1. Now, why? Let's go back to the question. That's how far it was from Earth in 2002. 12.1 times 10 to the 9th kilometer. So we're going to divide 12.1 times 10 to the 9th kilometer, which, by the way, is also 1.21 times 10 to the 10th power, because this is not in scientific notation. So let's do that. Let's do 1.21 times 10 to the 10th power divided by 1.08 times 10 to the 9th power. Right? So you can stop at the thousands. Well, you're going to get a long number again, so it's going to be about 1.1203. 1.1203, but let's just say 1.12 and times 10, because it's the power of 10. 10 minus 9 is 1. So that's the answer in scientific notation. But if we want to find how many hours that is, let's bring this up. Erase this. If you want to find how many hours that is, the exponent's telling you to move it once. So 1.12, move it once, that's 11 hours, basically. Or you could say 11.2 hours. So that's a more complicated question, but we'll go over more of those in class. Okay, and by the way, Pioneer 10, just because I go back to that satellite, we don't know where it is anymore. We lost its signal in 2007. So it could be anywhere out there in the universe. All right, so great job.